Hey, here we go, trying to find the errors in this question. So when I start questions like these, I always just kind of ignore the work they give, and I try to find the answer on my own first. So it says the diagram shows two circular sectors with an angle of 60 degrees. Okay, it shows that here. Then we have the radius of the smaller circle is 15 centimeters. All right, so it tells us that there. And it says the radius of the larger circle is X centimeters larger. So if I wanted to make note of that, I would say that the radius of the larger circle is the small circle plus X centimeters larger. So that's the combination of these two. So it's the 15 centimeters here plus the extra X. So we know the radius of the large circle is 15 plus X, and the radius of the small circle is just 15. So if I just want to find the shaded region, I need to take the larger circle. I need to find the area of the larger circle, and then subtract out the smaller circle that I don't want. So I want to get rid of this area in red, so that I'm left with just the area that I have up here in black. So if I use my formulas, so we know the formula of theta over 360 pi r squared. Remember, we're going to make this one the larger circle. Then we're going to subtract theta over 360. And then radius of the smaller circle squared. And then it tells us that the value, find the value of X so that the area of the shaded region is 16.5 pi. So it tells me that this needs to equal 16.5 pi. So let's sub in some of the numbers we know. We know what theta is, it tells us here. And we know where two radius is because we made note of them up here in the top. So when we sub in, we have 60 over 360 pi. Our radius of the larger circle squared is that 15 plus X squared. Then we want to subtract. Again, I'm subbing in 60 over 360 pi. We want the radius of the smaller circle, which is just 15 squared. We want that to equal 16.5. Let me just move all of this work over. About that. So this is 16.5. So then I can start to notice some things. So solving for X right now is going to be annoying, one, because there's X is in this squared. So we're going to start getting rid of some of these double things. So I can see that both of these terms have a 60 over 360. That means I can factor it out. Both of these terms have a pi. That means I can factor it out. So if I factor those out, I'm going to now have one copy of 60 over pi. Or sorry, 60 over 360 pi. That's going to leave me with this 15 plus X squared. And that's going to leave me here, of course the minus from the middle here, with 15 squared. So again, all I did was factor out those common things so that I can make this a little simpler on my life. And this still equals 16.5. So now I can simplify this fraction. So 60 over 360 can be simplified to 1/6. We're going to keep the pi. And then I'm going to start expanding out what's in the bracket. Remember, 15 squared means we have 15 plus x times by 15 plus x. So 15 times 15 gives me 225. 15 times x gives me plus 15x. X times 15 gives me plus 15x. X times x gives me plus x squared. Then I have this minus 15 squared, so minus 225. Once again, I run out of room. Lord, for technology. A little bit. And this is still equaling 16.55. Now we're going to start getting rid of some things to try to get these x's by itself. So I need to times by 6 on this side to get rid of the 1/6. And I also need to divide by pi. So I need to divide by pi here, while simultaneously timesing by 6. Well, dividing by pi is going to cancel out the 2 pi's here, same with here. So we really end up with, simplifying in here as well, 225 plus this time now 30x, combining these two together, plus x squared minus 225 equals, now we have 16.5 times 6, which is going to give me 90. Alright. I'm going to get rid of this now so we don't get confused with our work. So now, simplifying some more, I have a positive 225, I have a negative 225, so those are going to cancel out to 0. If I'm trying to solve an x squared, I need to set it equal to 0. So I need to move this 99 to the other side by subtracting. So I have x squared plus 30x and now minus 99 equals 0. So you can either solve this with your calculator using the polynomial solve function. You can solve it using graph and finding your x values. You can solve it by factoring it. So I'm going to do it with the polynomial function on your calculator, just so you can get an idea of what that looks like again. So we have our calculator over here. We're going to go down to this equation. So we're going to go to A. Let's make the screen a little smaller here. So we're going to go to equation, which is in A. Oops, too far. We're going to go into equation. We want to go into polynomial solver F2. Remember, the degree is the coefficient, or sorry, the exponent. So in our case, it's degree 2. A is the value in front of x squared. In our case, it's 1. So you can see I have a 1 here. B is the value in front of our x, so we have 30. C is our value that doesn't have a variable, so it's negative 99. So you go negative 99. Alright, so once you have all of that data in, we're going to go to solve. And you can see it gives us our two values of x's. So x equals 3, or x equals negative 33. However, only one of these really makes sense. Because if this was negative 33, then our circles don't exist. Because negative 33 plus 15 is going to give me a negative answer. So the only one that really makes sense is x equals 3. So now I have an answer, so when I spot the mistakes, I can just go through and see what doesn't match what I did and what they did. Alright, so I have a 360 pi out front. I have a 15 plus x being squared. Sorry, I was just trying to get it so it actually pointed a little bit. I have a minus 15x, I have a minus 15x, I have a 16.5 pi. So we can see that the first, second, and third steps are all correct. These are all good so far. They match exactly what I did over on the new side. So this is good, this is good, this is good. But here's where we start seeing a difference. They have 225 plus x squared, and I have 225 plus 15x plus 15x plus x squared. Then they have a minus 225 being squared again. So when they try to factor this out or expand this out, they did it incorrectly. So there is an error here. There is also an error here because they have another squared when the squared has already been done. So this is an error. Alright, if I keep looking. Alright, I times by 6 over on this side. They're dividing by 6 over on this side. So here's another error. So then they said x squared equals 2.75, and then they got a bigger number. So they should have square rooted on both sides, but they have another error here because they actually squared both sides. They went 2.75 squared instead of square rooting. So you can see there's a total of 4 errors here that we made in this first one. So that's just how I like to do it. You might have a different way that you like to do it, but I wanted to give you one situation or one way to think your way through it.